that bearing is defective. But if you could, I would always recommend running a bigger push rod. Bigger push rods are better all the time. Why do you not run a chain? Because chains are junk. That's why I don't run chains. Chains are junk. Got something a little bit different here for you. NA engine. Now, we actually built this engine about 5 years ago, maybe
Right.
6 years ago.
Right, about 5 years ago,
Yeah. NALS, really good piece. The original guy that we built it for, I don't know, bailed out for some reason, needed to, and he sold it to Jesse. And that's how we ended up meeting Jesse, was all through this engine.
That's right.
Because this engine has done what?
4 years, never broke. I haven't been able to blow it up.
And Jesse can blow up anything.
Yeah.
Quite literally.
I revved this thing to 9,300 RPMs.
So this has been in Jesse's burnout car in all-wheel drive. What do you call it?
The Nash Rod.
And so now it's back in finally for a freshen up. So Kyle and Jesse are gonna tear this thing all apart. I got be putting Rocky Bowler's engine together over here, so I got some other stuff I gotta do. So they're just gonna do a quick freshen up on this thing. It's gonna be kind of interesting to see how well this thing has just lived. We had done this such a long time ago. It's got the Edelbrock Victor LSR heads on it. I think this thing made, how much horsepower did this make on our dyno?
They made just over 1,000 on C16.
Yeah, just over 1,000 horsepower NA. This is one bad dude. Yeah, this is one of the bigger LSs that we've ever built.
Yeah.
And it's just been a really, really good running piece.
Oh, it's a workhorse.
Yeah, it's just been a workhorse. So it's gonna be very interesting. So as we tear this apart, we'll show you what's in it and how we built this thing.
Yeah.
And so since I can't remember what we did on it because it's so long ago, it'll be interesting. We'll see this whole thing. So let's get after it.
All right, so we've got our intake ready to come off. This is a CID intake, all port matched by Wilson Manifolds. So now that we got that off, we can take a look at our runners. Absolutely massive oval port. What these things flow, I have no recollection of, but I can tell you that is a lot.
It's supposed to be a lot.
It's supposed to be a lot,
Yeah.
and I think the horsepower numbers prove that.
Yeah.
So we're gonna continue on tearing this thing down. Okay guys, so you saw we took the intake off. Now we've got our valve covers off and our valley tray off. You can see up top here, we've just got these really beefy Jessel rocker arms, humongous push rods, a big beefy billet stand that they're attached to. I believe these are, ARP 2000 rocker arm shaft bolts. What this is as far as valve springs, I'm not 100% sure. Obviously it's all good titanium stuff. Everything's looking really good so far, and we're gonna continue on.
Kyle and Jesse got the cylinder heads off this, and now it's continuing to refresh my memory on what we did. So this is a Jessel 937 lifter, keyway lifter. I'll show you that. If you don't know what a keyway lifter is, so your conventional lifter, hello, get out of there, little buddy, is, you have your tie bar and whatnot. Darn it. These are very good lifters. But this is actually one of the reasons why I don't put them in drag and drive stuff. It's because you can't. It's very hard to get out. Yeah. So that is a keyway lifter. So if you've never seen a keyway lifter, that is what it looks like. And it does exactly what it says. It has a key. The lifter bushing, the bronze bushing right here, has a key slot. And that is what keeps the lifter located. So up, down, all around, but no, not all around. That keyway keeps it from turning. So they need to be indexed, and then obviously the bushings have to be put in perfectly straight. Otherwise, if you put this bushing in a little off, and then it's all of a sudden riding on the camshaft like that, that's a big problem, okay? So but very good. And these are offset lifter too. Now, the one thing that I was just talking to Jesse about here is I just came over after they got this apart, or this far apart, is they had, and he, through all the years, same push rods and everything through all the years, right?
Yeah, never changed.
Never done anything with this thing.
No.
But you must have had to check or done lash a couple times because it must have changed a little bit here and there.
So like the first half a year, I was real on it, and then it just laxed from there because I never had to do anything. You know, it was like maintenance free. Just put fuel and oil in it. And
Fuel and oil in it and go.
Yeah.
Well, it's got a push rod problem. Now let me show you these push rods because these are cool. Now we got a couple things. Jesel rocker arms, that's all normal stuff. And I had remembered that we actually had handmade these rocker arm stand spacers in order to get it up higher to get the correct geometry. And Jesel probably makes a stand now, but at the time they didn't make a stand, or I don't remember exactly why we did it, but probably might have just done it because we needed to get it done now. So that is a really good one-piece stand in that rocker arm. But we had to make these. We just literally cut these out by hand. I remember doing it now. Kind of ground them out. That's why it looks kind of cruddy, but they actually work perfectly good. Obviously, it's been there for 4 years. Jesse couldn't blow it up yet. It's probably gonna. We shouldn't even keep on talking like that because about it not blowing up.
Why?
Because that's just like asking for it.
Oh, yeah. No, we're gonna take a much better care of it this time.
Much better care. All right. So this is your non-typical manly push rod. This is actually a 9/16 push rod. So it's a 9/16 to half-inch single taper. Let me show you what the typical LS push rod has in it. So this is a 7/4. This is actually bigger. This is a 7/400. That's your typical LS push rod length.
Right.
And this is actually a 3/8 push rod. So this is actually bigger than the standard push rod that you can get away with in a lot of stuff.
Yeah.
I think that's a little bit different. There you go. You can definitely tell that overall size difference right there. Now this is a Manton push rod, obviously, and they have these really cool extended tips because this tip, you can't put this great big push rod in the lifter. Okay, so when this push rod, you see how far down this goes, especially with the offset. Is this an offset lifter? This is a centered up lifter. You could get away with it, but all keyway lifters have this step right here, and you just can't put a big tip down in the bottom. So it has to have this special hardened tip that allows it to have clearance on your sleeve and your push rod. So see how that goes over there? If that tip was not there, it would not allow any angle. It would not allow anything to happen. So that's why that's there. So, but to go into what the problem is here, is at some point in time, way back in the beginning, you said you had an oil pressure issue, and hot. It was like 5 pounds oil pressure idling.
Yeah, idling. Yeah.
Yeah, not running wide open throttle, but idling. And it probably, with a combination of oil and oil pressure, it had burned up. You see the bluing in there? Let me get you one that's not blued.
Come on, over here.
This is what they're supposed to look like. This is what, some of these exhausts look like. Not even all 8 it doesn't look like. Nope.
I think 5 of them.
Yeah. Yeah, five exhaust push rods have burned up tips right here. Now what that comes from is that is always, 100% of the time, it's always an oil issue. Always.
Yep.
There's nothing that wears out a push rod tip except an oil issue. So it could have been low oil pressure. Maybe it just started getting after it, but more likely it's a oil quality issue. Not enough zinc, not enough whatever kind of oil packages that we put in there of why it would burn up. This is a common issue, burning up any kind of push rod, valve train stuff. If you are, it is oil. Point blank. I don't care if your oil costs you $500 a quart. If it burns up push rod tips, it's still not the right oil. You know, it doesn't have the right oil additive packages. So expense and name brand don't really mean anything. But if you are burning that up, it's just oil. So we're getting him swapped over to our oil, the SM oil, what it affectionately calls Smoil, as soon as we get it all released here pretty quickly. Bill over at Driven Oil is actually doing it for us, and we're working through the oil packages, which is really interesting. So you've already paid attention to the rust inhibitor packages, and then there is a anti-wear package. Additive is different than a anti-friction.
Well,
Two different things, friction and wear, but you wouldn't think so.
no, but
But I guess I guess it makes sense if you think about it. But friction and a friction package and anti-friction additive is not the same as an anti-wear additive. So as soon as he comes up here, because Bill's going to be coming up here, he's the engineer that actually engineers all the oil. We're going to do this really cool video, and I'm going to de-nerd him some so he's more so he's more understandable, because he talks in oil engineer terms that there's like 10 people in the world that know what the hell he's talking about.
right.
I have a freaking idea. So I got to dumb them down just a little bit so everybody can understand them. But that'll be pretty interesting. But kind of remembering stuff as we go, because and this would be proof of it. So 9,500 RPM, you said?
93.
93.
Yeah.
I mean, the thing would run 10,000 RPM. That's a 10,000
Don't tell
RPM.
me that.
Well,
Don't tell me. Don't tell me
it
that.
cannot run 10,000 RPM. It is an instantaneous blow up.
Okay.
It's like 99.50. 10,000. Boom. Done. It's just like,
New rev limiter 99.50.
yeah.
Yeah.
Okay. So anyways, isn't it amazing that great big freaking push rod, and you need to think about this, that great big push rod, why does that not keep it from revving up? Wouldn't all that weight just be so much
I think
weight
it's
there?
linear. There's no leverage. It's just linear, right? It's like a balance point.
That's close. I think you're on the right train of thought. It's on the other end of the fulcrum. So
Yeah.
weight on this end of the rocker. Oh my gosh, this is good tech today. Weight on this is the fulcrum right here. Okay. Weight on this end over here means minimal to nothing.
Right.
That's why you can get away with running that push rod at 9,300 RPM versus that push rod. Now, you can't fit this push rod in everything. You can't even come close on most cylinder heads. But if you could, I would always recommend running a bigger push rod. Bigger push rods are better all the time.
Yeah.
Now, weight on this end of the fulcrum is a big deal. Everything matters over here.
Right.
So
it's like at least
valve, retainer, keeper, spring, everything matters here.
Okay.
Rocker arm design and tip, everything matters here. Does not matter over here. Minimal, if nothing. Otherwise, this thing wouldn't run 10,000 RPM. Don't tell. 9,000 RPM. Yeah, 9,000 RPM. So, just a little bit of FYI for you there. If you have questions, leave comments, questions. I'm more than happy to go over some stuff. And so far, I mean, and it's probably, if I had to guess, because of the way this is all worn in and shined back up, it looks like it happened early on, probably when you had the oil pressure problem. You said you changed oil and changed speed of pump or something.
Yeah, I turned the pump up. Yeah.
Yeah, turn the pump up and change the oil to a different oil, and all of a sudden it is shiny.
Repolished.
It pretty much repolished itself and probably stayed there for the last
I've
3.5 years.
So and the reason we swapped oils is because I kept seeing oil. I kept seeing metal in the oil,
Oh,
but it wasn't bearing. It was hard metal.
It was hard metal. It was
It was
that.
hard, yeah. So
Yeah. Well, that's what it was. Yeah.
yeah.
Just keep on tearing it apart. I think it looks pretty darn good so far. I mean, for what that thing's endured, it's got the same timing belt and everything on it.
Yeah, never. I'm telling you, I haven't changed valve spring. I haven't changed nothing.
Oh, we'll run the springs through the spring dyno and see what they've changed and what they do. That'd be interesting too. So we'll have Kyle run those through there. All right, continue on.
Cool.
And we have now got our pistons and rods all out. You can see our rod bearings look really good. They've just got these little striations in here that are probably just from foreign materials running through there, and not very big foreign material. And also we can see that our rings are not incredibly worn, but they do have a wear pattern all the way across the face of the ring. So it is time to replace these rings. You can see our free gap isn't really doing anything funny there, so it hasn't lost tension or collapsed or anything. It's just reached its point in life where it needs to be replaced. So 100% normal wear there. Everything else is looking really good. Pistons look really good. No scuffing on the skirts, so that's an honorable mention. Camshaft look good. Lifters look good. And right now, all we really need to do is take the mains out of it and take the crankshaft out and look at that stuff.
All right, so you got piston rods out of it. Everything looks good right there, right?
Yep.
Yeah, everything looks great. Pistons look good, rods look good. But I wanted to show you something. Notice, and this'll get the arguers going. Is this a 8 counterweight crank?
No.
This is a non-center weighted, non-counterweight crankshaft, spinning 9,300 RPM for too long, on rev limiter, loving life, not a problem.
Would an 8 counterweight be better?
What's I don't know, what's better than doesn't have a problem, ain't broke?
Yeah.
Nothing.
You know, so it kind of, I was only bring that up because theoretically it's better, and I fully understand what the premise of 8 counterweights is. But this is like just living proof of proper balancing. Got a cool balancing video. If you want to see the balancing video, go to this one right up here. Proper balancing, proper engine build, and it doesn't seem to care.
Yeah.
Because the only thing this does is this isn't a drag race engine. It's not accelerate. It's not even a circle track engine. It is where it still goes in the corner, accelerates out, accelerates. It doesn't do that. This thing just goes ba 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 all the time.
Yeah.
That's all it does. Ba 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 ba.
Something like that.
No, I think that's pretty accurate. Ba 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 ba.
Yeah.
There's axles flying out.
There's freaking there's other parts flying.
Oh,
out. You know, whatever.
Yeah.
So yeah. So interesting. I'd love to hear your comment on that too. Because is it better? Is it better in reality?
Maybe it depends on the combination. Maybe this combination at this cubic inches likes this. I mean, you would think balance is balance and neutral is neutral, but I mean, at some point, it's got to take stress and everything of how it's driven and what it's doing. It's got to be taken into consideration somewhere.
It's possible. There might be something there. I'll give you that. But for this one, it's working for sure.
I like it.
Yeah. All right.
Yeah, right all the money. Okay, so we've tested our springs. This is not going to be the final installed height. This is just the first installed height that I measured. We can go back and change this in the program, and it will automatically auto-populate all of these values in here. But you can see even at, 211 pounds on the seat, we've only got an 8-pound spread on our intake, a 6-pound spread on our exhaust. So that's less than like 4 or 5% spread between all the valve springs, which is plenty good. So we're gonna go ahead and set up our real installed height and then recheck them again and send it probably. What do you think, Jesse?
Look, man, if it ain't broke, you don't fix it.
Yeah, that's right.
Alrighty, so Kyle's got these cylinder heads all lapped in. Looked like a good.
Yeah, valve job was good. Just faced off the valves, so those valves are ready to go.
Yep, just touch the valve face, touch the seats, make sure everything is good. Looks nice. And checked his installed heights for the springs. Ran the springs across the spring checker. Spring dyno.
That's right.
They all look good. What? Oh, you told me what they were. Yep. So these have, what do they have with a Jim in it? 280?
265
265.
on the seat.
265 on the seat. All right, very good. And that gives us like 60-ish, 70-ish to coil bind.
Yep.
Okay. Nope, that's all good. So put a little dab of oil on them, shove them in the hole, put some valve springs on them. These are ready to roll.
Sweet. Let's
Sweet. Do it. Do it.
All right, guys, so we've got all of our parts laid out and ready to go to assemble. Now, the first thing I'm gonna do after we've already cleaned the block is we're gonna go ahead and gap our piston rings. So we've got our first, second oil ring ready to go. We're gonna go ahead and gap these things up.
Alrighty, so gotta go get fuel in the truck. And so we're now using and have been using the Upside app. I've seen other YouTubers using it, and it's like, oh, that's interesting. I think I'm gonna check that thing out. Happily enough, they use the exact gas station I go to all the freaking time. So that is perfect. It is just earning money, and that's awesome. So you go to your app, I bring up, oh, here's where I'm at. Yeah, look, oh sweet, that's the gas station I always use. So I click on it. Yeah, Speedway, go there, click on it here. We're just gonna drive over there right now. I'll just show you how easy it is. So we're here at the station. I'm already pumping fuel. I just have my app open, waiting to take do my claim so I can see what kind of money I earned on this deal. I'm gonna fill this thing up because I have a son that leaves my truck on empty every time he drives it. You know how it is. You know, so this is pretty darn valuable. And people are earning up to $280 per year just by using the app. That's crazy and easy. I hit claim. Upload a receipt. Upload receipt. Take picture. Continue. Is the entire receipt in the picture? Shoot, yeah, it is. Did you purchase between 12:50 p.m. and 4:50 p.m.? Shoot, yeah, I did. It's 12:52. Is gallons purchased shown? Yes. Is total paid shown? Yes. Everything looks good. Upload. Processing your cash back. You'll be notified in 2 to 4 days when it's ready. So I'm pretty cool with that. I'm figuring, looks like Dewey's gonna get a special treat today. I go fill up, earn enough money, probably earn more than enough money to buy the dog a treat. So to find out how you guys can do this, click the link below, download the free app, use Steve Morris to get an extra 25 cents off per gallon on your first purchase. So that's a bargain right there in itself. Or you can scan this QR code right here. So super easy. I highly recommend it. It's just earning money for going to the gas station, which you're going to do anyways. So super cool deal. And you can buy your dog a treat all at the same time with the money you earn. How could you get better than that? All right, now let's get back to the video. Alrighty, so on this engine here for Jesse, thought I'd show you a couple things, and because I said we'd show you what parts are in this thing to make this high RPM, high horsepower deal. So this is a 6,350 long Callie's Ultra billet rod, and this piston is actually a really nice diamond piston, and has a really small little ring pack. Now you notice this actually, for this kind of compression ratio, with this many cubic inches and that small combustion chamber on the cylinder head, it's like, I can't remember. I think this thing has, I think it has somewhere around 14 and a half to
14 and a half.
yeah, 14 and a half to 1 compression ratio, and it's dished. Okay, which is actually ideal. That's probably one little reason why it makes great horsepower. Anything that has, when you have this nice little conical dish in here, think about it as the flame kind of goes, whoosh, you know, well, it actually goes in,
Yeah,
so
yeah.
it get forced into the center of it and forcing it down. Versus having a dome up here where the flame travel's got to go across it, and it's just not as, it's not smooth. It's not nice. Okay, so just a little bit of simple stuff. If you can get a bunch of compression ratio in something with a flat top piston, golden. Conical dish like this, golden plus. All right. So now this whole piston package right here would last a 2,000 horsepower boosted level would probably last less than one burnout. This is not a boosted application whatsoever. This is all sorts of unhappy. This is the kind of thing where people come in and say, "Oh, I got this combination. Can we convert this over to a a boosted application?" I go, "Yeah, we can do it, but you're going to get a new crank, rods, and pistons because that's unusable." Why is it unusable? Why is this unusable, Nate? You've been here a long time. You know the answer.
The spacing of the rings.
Of the rings. Pretty much. Okay, so this whole ringland area is critical. So there's a couple things. A, this has a very small, that looks like that's a 031 ring. Is that a 031 ring? So this is a 031 steel top ring, a 031 Napier second ring. Oh, we had this question about, or actually as a comment, somebody said thinner rings make less tension. Yes and no. Typically when you get this thinner ring, the other thing that really sets tension is the radial wall thickness. Do you know that? See? This is free of charge. I'm teaching you stuff for free of charge.
Yes,
You're
yes,
welcome.
I'm sure.
Okay. So this thickness right here is called your radial wall thickness. Okay. From that face to the inside face, that's radial wall thickness. So the thicker that dimension, basically, the more radial tension, radial being tension it has on the ring. So that really is where it's all controlled. If it was thicker, yes, it adds a little bit, but the thicker as in vertical thickness, if it was a 16th ring, yep, it adds more tension. Well, 43 is less. 31 millimeters really less. Or, I'm sorry, 31 thousandths is really less. But it is this, because this is a it looks like a 150 radial or 150 radial wall. You got a caliper over here? This looks like a 150 radial wall, which means it is very low tension. The second ring on here, being 031, is also a 150 wall. Let's see. Oh, 150. It's a trained caliber eye. Actually, I just know what all these numbers are because I've seen it for so many years. So that is what makes this really light radial tension and piston ring tension. Then this also has, that's not even a 3 millimeter oil. That looks more like that is probably a 2 millimeter oil. Yeah, 1015. I think that's 2 millimeter, 2.5. So really small, very light ring tension rings, but they seal up very well. They have enough tension to seal in a nice naturally aspirated application. And if you recall from our conversations about gas porting, this has a lateral gas port.
Fancy.
Fancy. Yeah, fancy. Yeah. And so that is helping to expand out. If you want to go back and look at this video, that'll expand out and puts pressure behind the ring, forcing the ring out. So like just out to seal like that. Okay, so that helps that radial tension. If you didn't have a gas port in here, it'd probably still be okay. I don't think it would have any kind of problem, but it does aid in it and helps keep it better. So thought I'd just tell you a little bit about the ring stuff. And I know a good thing to do. What's your question? We'll ask if you got a question about this.
Well, I just want to know how nitrous will affect that. if at all.
This is not a good nitrous setup either.
Okay.
Not the best.
Okay.
Will it take 100 or 200? Yeah. You know,
Okay.
be gentle on it. Does this take a 500 shot? No.
Okay.
Nope. Just break stuff. Usually it'll break the ring lands on it. The ring, probably the ring would be marginally okay. You know, in a 1500 horsepower level total, probably be marginally okay, but it would break the pistons. It'd break something. But you could probably get away with a 200 shot at most, you know.
Okay.
But you're fully understanding that things break all the time. So there you go. All right. What else you got?
That's it from
That's
over
it
here.
from the peanut gallery.
That's right.
All right. So we're going to be putting this together, but we just ran into a snag, a problem, which is typical. So they're just laying everything all out, and we're letting Jesse help put stuff together. So Jesse just put the crankshaft in here, and this crankshaft is not a good turner. So
I broke it already.
he broke it already. So we're gonna take this back apart and see why this doesn't roll over nice, because it used to roll over great,
Yeah, it did good.
obviously.
Yeah.
So something's going on. I don't know if Jesse did something wrong or something's just. First thing I did is I looked to make sure the caps are facing the right way, and the caps are in the right order. Good job.
Yep.
Okay, but the crankshaft doesn't turn, so something's wrong. Something changed, and now this was an instance where Kyle checked the main bearing clearance just on one, because we just ran it through the line home just to double check, make sure everything's all good. So Kyle did not check all of the bearings, so maybe there's a bad bearing. Maybe there's something funny on one of the bearings, and that's what we'll find out here. So we'll keep you posted. We'll come back in here in a few minutes after we figure out what's going on. But we'll start having Jesse take this crankshaft back out. We'll start looking at bearings and see if there's. And he's right. The one thing we can do is do one at a time. So if you got something, so if you put a crankshaft in, did it turn over nice before you put caps on it?
Mm-hmm.
Okay, so turns over nice before you put a cap on it. A lot of times it's a good idea. You can put a cap on. You don't have to fully torque it, but at least snug it down like you did. Turns nice. Or you know there's a problem there, so you don't even have to go all the way through it.
Right.
So just putting them on one at a time, spinning it all the time. That's what we normally do. So I'll put a cap on and I'll spin it, put a cap on, spin it, put a cap on. When I spin it, I mean I'm just like literally just come over to the crankshaft and just
Yeah, I should turn.
I don't even give it a full turn. I just like grab it and touch it. So that's what we'll do right here. We'll do that. And see if we can figure out what's going on and show you what's going on with it. So we know what's wrong. Otherwise, it was going together really well.
Yeah.
Or actually, this is just the beginning going together. So
Yeah.
actually, you can't say
we're-
that.
I'm starting off bad.
It screwed off in the beginning.
Yeah. So as long as the finish is strong.
Yeah. Finish strong. That's what we need. Oh, this is also, so we talked about this is an extra tall deck block. So this is a is this a 500 block or I think this is a 500 block.
I think you're right.
Yeah, I think this is a 9500 deck height block, and this is a 4250 stroke crank. Is that right?
I think it's bigger than that.
Nope, I don't think it'd be bigger than that, but we'll do the math here. So I think it's 4250 stroke crank. This is a Cali's Magnum crank, and we talked about that not having the center counterweights. All right, and 55 millimeter camshaft still, so that's still a really good standardized thing in LS's. My personal opinion, there's not much sense going to 60 millimeter, 65 millimeter, whatever you want to put in it. The 55 millimeter just makes a really good cam core. Proven out, everything's great. Raised camshaft, so that means that from here to here is taller, higher dimension. Really keeps the rods from hitting the camshaft on big strokes. So as soon as we get this crankshaft out of here, we'll see exactly what the stroke is, because I'm pretty sure it's 4250. And yeah, we can figure out the math here. If you want to know super quick math, Nate?
Yes.
Okay. If you want to figure out how many cubic inch something is very quickly, all right? The math is bore 4.125 times bore 4.125 times 0.7854 times stroke 4.250 times 8 equals 454.
It's saying the 454.
How big is this?
4250 stroke, 4375 stroke.
This is bigger than that?
It's a 475 cubic inch.
Dang, 4375 stroke. That's crazy. Let's do the math on that. 4.125 times 4.125 times 0.7854 times 4.375 times 8 equals 467.
It's not a 4125 bore, it's a 4155 bore.
4155 board.
All your math is wrong.
Oh, no, the math is right.
Well, your
The,
math
the,
is right,
imp-
but
the input numbers.
The input numbers are
numbers are wrong.
What's that that they say?
4.155 times, yeah, garbage in, garbage out.
That's right.
4.155 times 0.7854. So 0.7854 is the magic number here. Times 4.375 equals times 8 equals 474. Has a longer stroke crankshaft in it than I was thinking. That is stroke, or that crankshaft is more stroke that is in my 540 that is in the wagon, my SMX, or in the better half Camaro.
Well,
That's an 1/8 inch more stroke than an SMX.
It's a long arm.
Long arm of
That's
the.
what Joe says, at least.
Is that what Joe says?
That's got a long
It's a
arm on it.
long arm. Yep. All right. So let's take that crankshaft out.
okay. Where's that got like a
that got
lump?
worse.
Is it the thrust? Well, maybe.
I don't know. That's
Where's your slide?
that's not rolling over at all now.
Ever since you undid one.
Huh?
Ever since you undid one. Where's your slide hammer?
All right. I would say no.
See?
That is the problem. All right, just out of curiosity, let's tighten up the rest of this stuff. Go backwards and see if it's just in number one.
That's how it's supposed to be.
Yeah. All right, so number one is definitely
Something's wrong.
something's wrong with number one. It has got
Do you think it's the cap or do you think it's the block?
I don't know. I measured the vertical oil clearance on this, but it did not measure near the parting line. I wonder if maybe it's got an issue there.
Like a T.
all right. So very interesting how this is working out. You will occasionally find this out, and this is why things all have to be torqued in order, like when we run things through the line hone, everything is torqued, because when things get untorqued, they relax or go back to some kind of natural position, natural state. That's a better terminology. Okay, so we took the cap off and looked at it, said, oh, look at that. It is touching the bearing here or there. They're on the parting lines out here. Okay, but the cap is registered tight, cap is dowel pin. It's like, okay, this thing is tighter than heck. These are loose. Okay, loose. Okay, Kyle, start tightening this up, and I'll be sitting here with my hand on it. See, that gets better already. Better. All right. So as we torque this up, it brings itself all back up and around. Kyle's got to change socket, gonna torque this other side up. But then all of a sudden here, this thing is moving and nice. So remember, things just have to get, will be untorqued. They're like torqued, everything goes back around. Wing dingy, ding ding ding. So crankshaft moves nice. That's nice. That feels perfectly good. Interesting that something in this, and it's probably been this, it has been this way obviously for, I would imagine, forever. Something is, wants to be torqued here to make it round. Fascinating. Which is we make things round when it's all torqued up. And very rarely, if ever, do we check if something gets unround when it's not torqued because we don't
It's
care.
irrelevant. Yeah.
We don't care. But this one just happens to be tight enough untorqued that it gets bad untorqued. So, anyways, that's interesting, eh?
Yeah.
I'm sure there's going to be some comments on that one.
Mhm.
Oh boy. All right. So go ahead and we're going to start putting this thing the rest of the way together. Showed you what crankshaft is, mains. That was interesting. Rings. Talked about the ring package, bearings, all that other stuff. This has 3.5 thousandths of bearing clearance on it. Yep. Verified all that. Didn't bother showing you everything there. All right. So we get this thing back together. All right. Check all of that. Forget everything I just said. Even though it is true, it just was bugging me. And it's like, what? Wait a minute. Well, the only reason we put bearings in it was just for the sake of putting new bearings in it, which I generally don't do. I've told you this before, that it's like, look, if this thing has perfect bearings in it, don't just put them right back in. They're happy. Everything's happy. And so it's like, oh man, we literally dug the old bearings out of the trash, found that number 1 bearing and said, here, put that back in there. And let's see what it does. And by golly, untorqued it turns and torqued it turns. So there has to be a problem with the bearing. So I grabbed my bearing mic, and this is why everybody wants to think, oh, just throw bearings in it, make it, it's they're cheap, throw bearings in it. No, if something is perfect, don't replace it. And this, I'm hoping this is, there's gotta be something going on here, because that just ain't right. Now here we are. That is 99 thousandths. Oh yeah. No, I guarantee you that's wrong. Okay. So in the middle of the bearing is, that is 100 thousandths, 104 tenths. All right. And then out here, it is, and I can't quite get to the edge because see how the mic won't measure quite that far.
Flip it around the other way.
No, because you have to have a, well, I could do that. Yeah, hold on. My bad. Let me do it this way. Again. Yep, it's 99. That side is, oh yeah, see, that's interesting. That is probably it. That is 98 on that side. And 99 on that side. That bearing is defective. Not only that, you can see, I'm not sure if you can see in the light, this is what the bearing looked like out of the box. You see it actually rubbing and scrubbing right there. It's worn this little coating off when we had it in the block, untorqued and turning it. So it's a 2-part deal. It's still getting pulled round by torque, which is normal. That's fine. But I just wanted to check it because I just could hardly believe what was all going on there. But this bearing, you put the other bearing in there, and it turned over fine. Or the bearing the original bearing back in there, turns over fine untorqued. Think about that. Going back to some things I told you earlier in one of the other videos where I talked about bearings. That was quite a while ago.
Mhm.
If Nate can find it, we'll put it right up here. Talked to you about bearings and how bearings are actually shaped. How bearings are not round in order to become round. So in a running dynamic condition, bearings are round. In a non-running condition, bearings are not round.
Okay.
Did you not watch that video?
I leave
Bill-
the engine tech to the engine builder. I just
Okay, so this is interesting. So the bearing clearance is always bigger at the parting line
okay.
because, so the bearing is, don't want to screw it here, hold on.
Yeah.
Don't want to screw up my bike. So the bore is basically shaped like that. Okay, kind of ovalish. It is literally shaped ovalish.
Right.
Because under load, what happens? It pulls
Yeah.
and makes it go round. So there is always, every time, 100% of the time, You cannot get away from it. It is physics, laws of the universe. In order for that bore to be round when it has a lot of load on it, you have to make it unround when there's no load on it. Plain simple fact. Okay. And this thing doesn't have enough unroundness.
Right. It's the opposite, right?
Yes.
It's
It is
thicker in the
too god darn tight. It needs to be thicker in the middle, thinner out here. That makes it
Yeah.
more clearance here,
Right.
less clearance here. Okay. And then it pulls back around. Now here, so this little bearing, this is one of the used bearings out of it. We'll see what this is. Oh, it's S98. So that little one thousandths of clearance in a bad deviated bearing was giving us just a little bit of fit. It just was like, it's just something more off than normal. And that's what it was.
Yeah.
There you go. So if you're feeling like it, you can check all your bearings. You need to get a little ball tip for your mic and you can check bearings. But that's pretty interesting. Usually I'm just telling people that's the kind of stuff that happens. It's pretty rare that I get to show people that a actual bad bearing. It's rare, really rare. But all right, now we'll get back at it. All right, so you can see they got the big oil pan on it, big pan for a dry sump pump, dry sump pan. So you got a tank on it, right?
Mm-hmm. Yeah.
That's a big pan for a dry sump, but that's all cool. It's a nice pan. Show you here on cylinder heads. Now I like these LSR heads. So this is a Victor LSR head. Now the one thing that you have to do is it does take the CID intake manifold with spacers because this is an extra tall deck. So this actually must not be. What did we determine that the deck height would be on this? This must be the 9700 deck height.
Maybe because it's got like a 1/2 inch spacer on that intake.
Yeah, 9750 or something like that.
Yeah.
Yeah. And I think we might have misspoke earlier. This would be a 9750 deck height block. So the intake manifold, because these heads don't take your normal LS stuff, so it takes that CID intake manifold, and you can see by the bolt hole pattern and everything, and which is a great manifold. Obviously, those things work real well. But we had to put the 1/2 inch spacers on them in order to get it to fit because of the extra tall deck block. So tall deck 9750 LSR head, our full port package on there, Cometic style multi-layer steel gasket, not a boosted thing. This thing makes awesome horsepower at 1,000+ horsepower, but it's not needed to have the O-ring and the SMX hoops, that fire ring setup that we put in there. So we don't have to do that, but we did, per Jesse's request. We machined in a O-ring, just put her up in the CNC machine and the old 5-axis machine, and plowed a nice little O-ring in there for his headers because they don't have, what was it, your header flange just didn't, or nothing fit this particular port for a
Yeah, the
gasket.
The gasket, yeah.
Yeah, for gaskets. So O-ring this thing. So these things are ready to go on. And then I had already shown you some of that valve train stuff where we had to build the shim to make the rocker arm stand height correct. Here on this Pontiac right behind you, I do a whole little detailed explanation of stand, rocker arm height, how to determine your push rod. And maybe we'll go over that real briefly on this as we're putting the rocker arms on. But upcoming in this Pontiac video is going to be even more detailed explanation of stud mount rocker arms and how they adjust and how you set valve, or how you check your valve train geometry and push rod length versus a shaft mount like this is. So I think that'd be interesting. I'll show you how you do it on the shaft side of things, or on that Pontiac I showed you how to do it on, which is coming up. That video is not out yet. It's going to be how to do it with a stud mount, because it's stud mount. So go ahead, put these things on. We'll put our Mogambo big push rods in there. And it's an interesting thing too, that these are actually a bigger diameter push rod than I put in the SMX, which is pretty interesting. And that all goes to prove that whole point of what we just talked about earlier, is on the valve train dynamics and how stuff runs, and weight isn't important over here. Why do I not have a bigger push rod in the SMX? There's actually a little interference issue inside the intake port and the valve train. Not needed, obviously. And could I use these or build something to make these work? Probably, but I really don't feel like reinventing the wheel, because there's some water jacket issues and things in there that I can't make everything fit in the world. So that's why I use a 1/2 inch push rod on the SMXs. This is maybe overkill, but the point of the overkill is it doesn't have any negative side effect. So could I get away with a lot less push rod? Yes. Would it have a benefit? No. Does it matter? No. Bigger's better? Yes. How about that? Alrighty, 2 things for a last bit of tech information on this engine and engines in general. Remember, everything applies. Doesn't matter if it is this engine, your stock LS engine, doesn't matter what it is, it all applies, okay? So going over this little bit of valve train geometry, I showed you earlier about the shims that were underneath the rocker arm stand to raise that rocker arm stand up, okay? So what that is doing is it is raising our fulcrum height. All right. Now I have a longer video on this Pontiac engine right here talking about this and how we had to do it with the stud style. Push rods are coming from Manton for that one. And so, but this one has already been running, so I thought I'd show you the proper geometry and what it looks like on the valve. So when we raise this fulcrum height on a shaft rocker arm, it just literally just raises the fulcrum height. We get the motion on the valve tip right by adjusting the shaft height. Once that shaft height is there, measure the push rod. Don't put push rods in it and move your shaft height to match everything. Move your shaft height to get your valve tip correct. All right, so what we're going to do here is we're going to put this little bit of CMD lube on the valve stem tip, and you kind of see it's brown. So I'm hoping this will leave a nice little trail, a cleared off trail of where the rocker arm is riding. Okay, now I've already lashed these things, so we'll roll this over. And you can see this go through its sweep motion. Hopefully it'll do a nice job of giving us a little grease imprint.
Yeah.
Yeah, not too bad.
Yeah, you can see it.
Interesting.
Right in the middle.
All right, yeah, that was very good. You can see, can you see that real good light reflection?
Yeah, really good.
You see how that is right in the middle, very minimal amount of sweep. This one is maybe not quite as close to the middle, it's upwards a little bit, cannot correct that. No matter what you do in raising or lowering or push rod length, you're not going to be able to correct that because it will get wider if you raise the stand. But then since this is a one-piece stand, it is what it is. you can't separate it. If I raise this, then it makes this one wrong. And that one is 100% acceptable and nice and perfect. Okay, it just doesn't look perfect, but we can see there here very clearly how wide that is. Looks like it's about 60 thousandths or so, 60, 70 thousandths. This one looks like it's about the same, but it's right there to right there. This one is right dead in the middle, there to there, which is perfect. This one just happens to be a little bit farther up, but like I said, there's nothing you can do about that. Now, as you would move this through its motion of raising the stand, it is always, if this was my valve, it's going to basically start over exaggerated. It's going to start over here, and as it goes down, it comes across, and then let's see, hold on. So it starts over here on the back side, comes down right in the middle, then comes down and goes a little bit over here. So let me do this real exaggerated. Starts here in the middle of the sweep, middle of lift, it's there, and then it goes back down to over here. Very exaggerated, okay? That's where you get that sweep on. So middle of, in an ideal world, middle of your lift, it is right dead in, basically right dead in that middle range. Anywhere else, it's just slightly off to one side at the start, slightly off at one side on the end, but right dead in the middle at middle lift. That's what you're wanting to see. So you raise your rocker arm stand height with shims to the correct dimension so it will have a really nice sweep pattern, correct sweep pattern, and then measure your push rod where it's at. All right? So that is how you do all that. Like I said, we'll have a little more detailed video when the Pontiac comes out, but that's a good illustration. You understand what the shaft is? All right,
Yeah.
very good. All right, now, another question we always get. Why do you not run a chain? Because chains are junk. That's why I don't run chains. Chains are junk.
Okay.
You ever seen an LS brake chain? Ever heard of an LS engine breaking a timing chain?
Not personally, no, I have not.
But you've
but
heard of
they stretch and yeah,
they stretch. They get nasty. They stretch. They get real bad. As of yet, come here. As of yet, have not ever broken a belt. Probably going to happen tomorrow now. But I did knock on Jesse's head, so that's a
As
good.
long as it ain't this one, I'm okay.
That's it.
Yeah.
The belts are astronomically tough. The belts don't stretch. I have no idea how that's even possible. They don't ever seem to stretch. The belts are very tough, very resilient, last a very long time. The only thing that would screw up a belt typically is if you get something stuck in between there, or if you blow the engine up and it stops the camshaft from turning, then it shears the teeth off of it. But you can think of like blower belts, all those other things, very, very, very durable. And the camshaft, they just are very durable. The reason why we would use them is infinite amount of adjustability with a belt drive. Much easier to change camshaft timing, adjust, move, whatever we want to do for testing. And they absorb harmonics. So they do a very good job of not transmitting whatever's going on in the crankshaft to the camshaft. A chain will transmit harmonics because it's very solid. There's no give to it.
No.
Yeah. So, and gear drives transmit all the harmonics to it. The gear drive is the ultimate for strength, point blank, period. No, nothing better. I like the belt drive as far as nothing better for harmonics getting transferred into the camshaft. Nothing better than the belt. Does the best job of preventing that. Timing chains are I've personally broken timing chains and don't have any. I try to get away from them as much as possible. In general, they're fine. For your general regular engine, they're fine. But nobody is going to put a timing chain on an engine like this. That's just be ridiculous. On this particular engine, I think it's even pretty hard to put a timing chain on it.
Yeah, yeah.
So it doesn't actually fit particularly well. So anyways, always get that kind of question. Now let's answer questions from Tuesday's video, which was all about the Streamliner engine over there. So let's answer your questions. And I think we'll get Joe over here. We'll leave, yeah, we can get Joe and Kyle over here, and we'll leave Jesse in here too.
Special guest.
The special
Q&A.
Special guest Q&A.
All right. Oh,
All right.
boy.
Oh boy.
Oh boy.
Alrighty, so to answer the questions from Tuesday's video, which is about this engine. Now, if you haven't seen this Streamliner, see Streamliner? This is what a Streamliner is. Okay? Now, we are going to be shooting for the world's fastest piston engine car. Period. Okay, so that's what this is all getting built for. 4 different engines, 4 different sizes. It's a long story, but there's all sorts of stuff that goes on there. 4 different engines, yeah.
Wow.
Yeah, and yeah, so this is a big deal. So if you've missed this video, all you gotta do is just go back one video and you can see it. It says 4,000 horsepower and we had one thing. That's what we're gonna be answering a question about what happened that stopped us from making 4,000 horsepower. Now, ironically enough, it cannot make 4,000 horsepower on salt flats. It won't take it. They've run every simulation. We know exactly how much horsepower it takes to make it amazing amount of stuff. So the 4,000 horsepower was just for the standpoint of just saying we just made 4,000 horsepower, which is going to be easy until the cam sync locked up. So some common questions that we heard was, and I can let people answer it. Common comment: oh, did the oil pump lock up first? No. Here's the shaft. I'm still turning the shaft. It's no big deal. Okay, no, it's a little hard to see, but turning the shaft. Okay, the oil pump didn't lock up. How do I know the oil pump didn't lock up? A, I just checked it, and B, this is locked up because that welded itself together. If the oil pump locked up, it would just break the shaft and stop turning. It wouldn't bother to weld this together. What happens in there? There's roller bearings in there. Something pulled this down. I think this actually went like this, loosened up because this is threaded, allowed this to come down. When it did, this hit because it didn't have enough clearance, welded itself together. Okay, that's what happened there. A real other common question was, and I'll see if the guys know this. Oh, I'm sorry. For tonight's video, you've already been seeing this guy's face all over it. And I thought, all right, we're going to have a special guest appearance in the Q&A section. Jesse Jordan.
Hello.
Yeah. Okay. So another real common question, I can't show you, but we'll just you have to revert back to the clip. I thought this was a really interesting thing. You could see how much during the first pull of this engine, where the inlet sucked shut. Okay, and a lot of people jumped on there with a partial truth, but they're not thinking about the whole thing of it's ambient pressure. You put a vacuum in it and ambient pressure crushed it. It's like, okay, that's part way. Ambient pressure is 14.5 pounds, right? But I showed you that in order to move that far, it took almost 60 pounds of pressure to move it the same distance that we saw it move. I mean, I was literally on a scale pushing it and going, trying to crush it. It took 60 pounds of pressure. So it's more than just the ambient pressure. That makes sense?
Yeah.
Yeah, that makes sense. Okay. All right. So here is my favorite question, and we'll see if everybody's got what kind of good answers people got. Favorite question here is from Peter Summers, 3014. All right. So make sure that you contact me because I'm not going to contact you to send you free stuff. So contact us, okay? Just send an email to the main email address. Okay, since we mentioned oil pumps in today's video, it brings up my questions. What oil is being used in this engine and what viscosity? That part I'll answer. Our oil, we're having our own oil made for us by Driven Oil. It is a special multi-weight primarily drive, methanol compliant, rust inhibitor, certain really special stuff. Very excited about it, coming out real soon. But that's why it's really cool looking green. It's our oil. It is going to be something special. It's a 2560 weight. So 2560. Very cool. All right. But let's get to the other question here that I thought was interesting. I know dry sump oiling is superior method in oil control, but I have recently heard that Proline engines are a wet sump. Builds like Garrett's Eagle does not have a dry sump tank. I'm interested in your answer, Steve. Do we know what's going on there in the Hemi engines? What is going on with the oil pump?
I'd have to see it to know what they're asking, but is it a hybrid dry sump where it uses a dry sump pump, but the oil remains in the pan?
Okay.
Yeah, as far as I know, the pump mounts exactly like how this pump mounts, right off the side of the block. And is driven by the cam sync / distributor. So it's technically a wet / dry sump because it's an external Billy Bad Boy billet pump. It just doesn't have a tank it's picking up off the pan. So it's not doing anything other than going in a straight line.
Yeah, I'm gonna say I've seen them on other engines where it's an internal dry sump, right, where the
Yeah.
oil is stored in the engine, but it's also
Wow.
but it's got
And
an
that's
external
how
pump.
that's how the oil pump is set up on my car, Blueberry. It
Yeah.
is a wet sump pan with an external dry sump
Yes.
oil pump.
Ding, 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 ding. All three of you guys
Yeah.
got the right
All right.
answer right off the bat.
It's almost
Yes,
like they do that.
just like this. This is a Auto Verde dry sump pump. The pump is outside of the engine, which means it is a dry sump pump. It does. This particular motor does have a dry sump tank. Nobody's looking at it. Here's the dry sump tank. There's the dry sump pump. It is a dry sump pump system. It is mechanically driven through a shaft instead of through a belt. That's the only difference in this whole thing. It's just driven through the cam sync. All right, and that was a pretty common comment too, or question was, why does it not have a dry sump pump? It does. It's right there. The whole system is right there.
What I think is pretty cool about that pump, by the way, is the fact that the rotors are still parallel.
Yeah,
with
the whole
block.
pump, the whole pump is still
So-
parallel with the engine, which is interesting. Now, on the second part of that question, there is, I have recently heard that the Proline engines are a wet sump. They are not. It is exactly like this.
They do build wet sump engines and they sell wet sump engines.
No, you can't do it in a wet sump engine. It is not a wet sump engine. It's a different style pump. There is no Hemi in the world that has an oil pump inside of it.
Right. They're all.
They're all right there.
Yes. But
They're
is that technically not
extern-
considered a wet sump?
No, we just discovered that. Well, that is still
So
a
it's
dry
wet
sump.
Dry sump.
Yes, it's a wet dry sump. It is oil in the engine. Just this one is not because there's the oil tank, but it is the same pump or same style pump. They would probably use a System 1 pump, which is a little bit different, but the pump is not in the engine. Therefore, it is a dry sump pump.
Well, no, it's
It is
just
not in oil.
it's an external wet sump because the oil's still in the sump of the pan.
Right. The oil is in the pan, but the pump is not in oil. So therefore, it is a dry sump. Dry sump pump. It is a dry pump. This is just a dry pump.
This is an external
Right.
wet sump.
Yes. Okay, we're gonna have to reevaluate this
Well, 'cause
guest.
some of
This
the
guest.
more
This guest
setup-
speaker.
Well, because some of the Mopar setups have the external line goes through the pan, and then you technically have a sump in the pan.
Right. The sump is part of the pan, so you are sucking oil from the pan. So I stand corrected. Like I said, we're gonna have to reevaluate this whole cast.
Just
Is it?
If you're gonna be correcting,
Well, I just
Ah.
I'm only kidding.
Is this
Yes.
guy's question really? I think this guy's really asking why don't they run on some engines a oil tank?
Okay. Because it's really not needed. Now, there is an interesting side note to that. Hemi engines, 41Xs, even my SMX, are notorious for holding engine oil in the engine. So when they put a pan on, in general, this is not specific. I'm sure somebody out there that has a Proline Hemi is, I don't have one, obviously. So I don't know exactly what it is, but typically you would have about 12 quarts in the pan for 1/8 mile racing, and you need to have 16 quarts in the pan for 1/4 mile racing. So it quite literally would run out of oil going down track if it doesn't have enough oil in the pan. And they'll overfill the snot out of these things, and they'll crankshaft starts up with oil crankshafts riding through oil. They'll overfill them. So I don't know, maybe Proline isn't doing that, so don't send me hate mail if you know that they don't. But that's just in general statement. They actually have to add oil to these things in order to get them to run the quarter mile without sucking the oil pan dry.
I'd say another thing about having the external oil tank is that you can control the temperature of the oil separate from the temperature of the engine. Like these guys are liking to heat up the oil before they even start the engine cold.
Yeah, but you could put a probe or
Yeah,
oil
you can.
pan heater.
But I don't know if maybe it's better to, I don't know. Maybe it's just
I
more
always
control.
thought it had to do with the center of gravity of the car. Because you're leaving the oil in the pan at the lowest part of the car versus having a tank with 3 gallons of oil, which is X amount of weight, that can move around.
Yeah.
That's what I thought. That's what I thought it was
I
about.
mean, that's probably not the main reason, but I mean, that's definitely a reason.
Because I mean, that oil even sloshing in that tank is going to give you weight transfer and a weight bias change.
Well, there's
That-
bathrooms in it and stuff that keep the oil, you know, but
Well, oil.
See,
Yeah, but,
I'm not
but
going
if
to
you
disagree.
leave the lid off of it, I bet oil comes out of the tank.
It
Sure.
it does, yeah.
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 I'm not going to disagree with the theory, but the practicality is astronomically minimal. Now, if you're moving weight in the car, that's different. But the slosh in the pan and
Well, yeah.
they
No.
work that way.
I mean,
Not in reality.
Yeah, it's minimal.
Yeah, it's minimal.
That part's minimal.
All right, so that's it for today's video. If you like these kind of comments, if you want to see more guest speakers come in and correct me, we can probably manage to do that.
I can come back.
You can come back.
Yeah. I can.
Make sure you leave a comment about this video on Jesse's engine because we'll come back and there's a lot of content in here. So, and if you have not seen this, you should see this thing because this is probably the best sounding engine, a turbo engine in the dyno room I think that we've ever had here. I mean, it is. I don't know if it's because we videoed on the cell phone in here, so it can't the microphone was much better, but it's screaming. It's really cool. So, anyways,
Sorry,
I'm Steve
Steven.
Morris. That's
Double A Joe.
Kyle.
Kyle.
Cow. Damn it, cow.
And that's Jesse. And that's Dewey. There you go. Camera shot of the dog. He's coming in.
The whole crew's here.
crew's here.
All right.
Have a great day. I appreciate all you guys.